Dear students, in this class, I'm going to continue with the topic surface area and volume. As far as I know, you have already done the surface area and volume of cube, cuboid, and cylinder. You have already studied a part of solid right circular cone also. So today I'll just do some questions based on a right circular cone. Before starting the questions, just a quick recap of the formula we are going to use in this right circular cone. Right circular cone. Now this is the shape of the solid. Now why this cone is called a right circular cone? Because this is called a right circular cone because its base is a circle. This is a circle, and the line joining the center of that circle, that is at the base, with the vertex is actually perpendicular or at right angle to the base. That means this angle is 90 degrees. Clear? So I repeat, this solid is called a right circular cone because the base is a circle, that is why it is circular, and the line joining the vertex with the center of the base is perpendicular to the base or right angle to the base, that is why it is called a right circular cone. Now this is the height of the cone, that is h. This is radius of the base. H is the height. R is radius of the base. And this side, this length is denoted by small l, and it is called the slant height. Okay, so this length is called the slant height. Now as you can easily see that H, R and L, they are the three sides of a right angle triangle. So if any two of them are given, then the third one can be calculated using Pythagoras theorem. Clear? H, R and L. Out of these three things, if they have given two things, you can find out the third using Pythagoras theorem. Now the formula, first of all, volume, that is 1 upon 3 pi r square h. You have already studied that the volume of a cylinder whose base radius is r and height is h is pi r square h, but the volume of a cone is 1 upon 3 pi r square h. The derivation of this formula is out of the scope of this book. Now curved surface area, that is this area, that is the curve, excluding the base because the base is flat. So the curved surface area of a cone, it is pi r l, where you know pi, for pi we use 22 by 7. Sometimes it is given that pi is equal to 3.14, then we take that only, but otherwise pi is 22 by 7. So the curved surface area of this cone will be pi r l, where r is the radius of the base and l is the slant height. Now total surface area, pi r l is the curved surface area and area of the base is pi r square because it is a circle, and all of you know that area of a circle is pi r square. Now if you take pi r common, then in the bracket you will have l plus r. So this is the formula for total surface area. Clear? So in various questions we will use these formula. Okay, so the first question is, the slant height of a cone is given 10 centimeter and radius of the base is 7 centimeter. Find the curved surface area. Find the curved surface area. So you know the formula for curved surface area of a cone is pi r l. In place of pi, you put 22 by 7. R is given 7 and L is 10. So the answer will be 220 centimeters square. The answer is 220 centimeters square. Clear? Now, next question. The height of a cone is 16 centimeter and the base radius is 12 centimeter. Find the curved surface area and total surface area. Curved surface area and total surface area. Take pi is equal to 3.84. Now in this question they have given that for pi you have to put 3.14. Now curved surface area, first of all they have given the height of the cone as 16 centimeter and the base radius is 12 centimeter. Now to find both the curved surface area and total surface area, we need the slant height. So to find out the slant height, we will apply Pythagoras theorem in this right angle triangle using Pythagoras theorem. L square is equal to 16 square plus 12 square. Now you know 16 square is 256, 12 square is 144. When you add it is 400. So L is equal to square root of 400, that is 20 centimeter. So we have calculated that the slant height of the given cone is 20 centimeter. Now curved surface area. The formula for curved surface area is pi RL. For pi we have to use 3.14. R is given 12 and L we have found 20. So it is the answer will be 753.6 centimeter square. 753.6 centimeter square, that is the curved surface area. Now we have to find the total surface area, and the total surface area will be pi r within brackets L plus r. Pi r then within brackets L plus r. Now again for pi you use 3.14, r is 12, L we have calculated 20 and R is 12. Three 3.14 into 12 into 32. Okay, so 3.14 into 384. So you have to multiply 3.14 with 384. So the answer will be 1205.76 centimeters square. The answer is 1205.76 centimeters square. That is the total surface area. This is curved surface area and this is total surface area. Now the next question. Diameter of the base of a cone is 10.5 centimeter and the slant height is 10 centimeter. Find the curved surface area. Now this time, instead of the radius of the base, they have given the diameter of the base. So all of you know that radius is equal to diameter upon 2. So radius is equal to diameter upon 2, that is 10.5 by 2 centimeter. And slant height they have given 10 centimeter. Now you know the formula for curved surface area is pi r l. For pi you use 22 by 7, r is 10.5 by 2 and the L is 10 centimeter. Okay, so if you remove this decimal here, there will be a 0 cancelled, it is 11 here. Now 15 into 11 will be 165 centimeters square, and that is your answer. The answer is 165 centimeters square. Okay, next question. Diameter of the base of the cone is given 24 meter and slant height is given 21 meter. The slant height is given 21 meter and you have to find the total surface area. Find total surface area. Find total surface area. Now radius of the base, that is R, is equal to 24 upon 2 means 12 meter. Now you know that formula for total surface area is pi r within brackets L plus R. Okay, that means 22 by 7 into R is 12 and within brackets 12 plus 21. Within brackets this is 12 plus 21. 12 meters the radius and slant height is 21. So it is 264 upon 7 into 33. So first of all you multiply 264 and 33. Eight seven one two. 8712 upon 7. Now you have to divide 8712 by 7. So it is nearly 1244.57. It is nearly 1244.57. 1244.57 centimeters square. Sorry, meters square. That is the total surface area of the cone. Now the next question. Slant height of a cone is 14 centimeter and curved surface area is 308 centimeters square. Find first part radius of the base and the second part total surface area. So you have to find the radius of the base and the total surface area. Now what we do, you know that the curved surface area, the formula for curved surface area is pi RL. So the curved surface area they have given 308. So in place of curved surface area you write down 308. Pi is 22 by 7. R we have to find. L they have given the slant height 14. So first of all it is cancelled. So R will be equal to 308 upon 22 into 2. Okay. So R will be equal to 308 upon 22 into 2. Now you cancel it by 2. And now you cancel it by 2 again. And then by 11. So the answer is 7 centimeters. So you can see we have found the radius of the base of the cone is 7 centimeters. Okay. Now in the second part you have to find total surface area, and the total surface area, the formula for total surface area is pi r within brackets L plus r. The pi is 22 by 7. R is R we have found, that is 7. Okay, and L plus R means 14 plus 7. This 7 gets cancelled. So 22 into 21. 462 centimeter square will be the answer. The total surface area will be 462 centimeter square. Clear? And the radius we have already calculated 7 centimeter. Now the next question. Next question, find the capacity of a conical tank with base radius is 7 centimeter and slant height 25 centimeter in liters. Now they have given the base radius of the conical tank and the slant height, and you have to find the capacity. Now the capacity means the amount of water it can hold. That means you have to find the volume. But for volume, you know the formula is 1 upon 3 pi r square h. That means we need h. So first of all, we'll find out the height. So for that, this is the tank, conical tank. The radius of the base is given 7 centimeter and the slant height is given 25 centimeter, and now we want the height. So for that, using Pythagoras theorem, h square plus 7 square is equal to 25 square. H square plus 49 is equal to 625. H square is equal to 625 minus 49, that is 576. Okay, 576. So H will be equal to under root 576, which is nothing but 24 centimeter. So we have found the height of the conical tank. Now volume. As I told you, the formula for volume is 1 upon 3 pi r square h. That is 1 upon 3. Pi is 22 by 7. The radius is 7, so 7 into 7 because r square is there. And h we have calculated 24. H we have found 24. Now first of all, this 7 is cancelled and 3 8s are 24. So 22 into 56. When you multiply, one two three two centimeter cube. 1232 centimeter cube is the volume of the tank. But in the question, if you see, they said give your answer in liters. So you know in 1 liter there are 1000 centimeter cube. 1 liter is equal to 1000 centimeter cube. That means to convert this 1232 centimeter cube into liters, you have to divide it by 1000. So 1232 upon 1000, that is 1.232 liter. 1.232 liter is your answer. The answer is 1.232 liter. Clear? The answer is 1.232 232 liter. That is the capacity of the tank. Clear? Now, the next question. Find the volume of a conical tank if R is equal to, that is the radius of the base, is equal to 6 centimeter, X is equal to 7 centimeter. The height is given 7 centimeter and radius of the base is given 6 centimeter. Now you know that volume of a cone is 1 upon 3 pi r square h. That is 1 upon 3 into 22 by 7 into 6 into 6 into h is 7. Clear? Now 7 gets cancelled. 3 to the 6. So it is 44 into 6. 264 centimeter cube is your answer. The volume of the tank is given 264 centimeter cube. Okay. Now the next question. A joker's cap is in the shape of a cone of radius 7 centimeter and height 24 centimeter. Find the area of sheet required to make 10 such caps. Now see, they have given the radius as 7 centimeter and the height as 24 centimeter. Now we want the area of sheet required, that means we want the curved surface area of the cap, because the base is open in case of a cap. So only the curved surface area of the cone we have to find. But to find curved surface area we need the slant height. So first of all we will calculate the slant height. So this is the cone or the conical cap. Now this height is given 24. The base, the radius of the base is given 7, and slant height you have to find. So first of all we will apply Pythagoras to find the slant height of the conical cap. Using Pythagoras theorem, L square is equal to 24 square plus 7 square, that is 576 plus 49, that is 625. L is equal to under root 625, that is equal to 25 centimeter. So we have found the slant height to be 25 centimeter. Now curved surface area of each cap will be pi RL, that is 22 by 7, R is 7, L we have calculated 25. Now 25 into 22 is 550 centimeter square is the curved surface area of each cap, but we need 10 such caps. Area of sheet required for 10 such caps will be equal to 550 into 10, that is 5500 centimeter square, and that is your answer. Clear? Okay. Now the next question. Next question. Height of a conical tent is 10 meters and the radius of the base is 24 meters. Find the slant height and the cost of canvas and the cost of canvas required to make the tent if the cost of 1 meter square canvas is rupees 70. If the cost of 1 meter square canvas is rupees 70, that means again it is a conical tent, so we have to find the curved surface area, because in a tent the canvas is not put at the base, only the curved surface area. So for curved surface area we need the slant height. So in the first part we'll calculate the slant height first. So this is the conical tent. The height is given 10 meter and the radius of the base is given 24 meter. Let the slant height be L. Using Pythagoras theorem, L square is equal to 24 square plus 10 square, 576 plus 100, 676. So L is equal to under root 676, that is 26 meter. So the answer to the first part is 26 meter. We have found that the slant height is 26 meter. Now curved surface area. You know the formula for curved surface area is pi r L. Okay. Now the value of pi is 22 by 7, r is 24, and L we have calculated 26. Slant height is 26, the radius of the base is 24, and pi is 20, obviously 22 by 7. Now see, 528 into 26 upon 7. So first of all, you multiply 528 and 26. 13728. So it is 13728 upon 7 meter square. You don't have to divide it, because when you find the cost, that you will multiply it by 70, because cost of 1 meter square is 70, then 7 will be cancelled. So cost of canvas is equal to 13728 upon 7 multiplied by 70. So it is cancelled 10 here. So the answer will be rupees 137,280. 1,37,280. That is your answer. The cost of the canvas required will be 1,37,280. Okay. Now we will do the next question. Next question is the slant height of a conical building is 25 meter and the diameter of the base is 14 meter. Find the cost of white washing its curved surface area at the rate of rupees 210 per 100 meters square. Find the cost of whitewashing its curved surface area at the rate of rupees 210 per 100 meters square. Now, slant height is given 25 meter and radius will be diameter upon 2, that is 14 upon 2. 7 meter is the radius. Now curved surface area is pi RL 22 by 7 into 7 into 25, that is 25 into 22, 550 meters square. So the curved surface area is 550 meters square, or the area that has to be whitewashed is 550 meters square. Now cost of whitewashing 100 meters square is equal to rupees 210. Then cost of whitewashing 1 meter square will be rupees 210 upon 100. Then cost of whitewashing 550 meters square is equal to rupees 210 upon 100 into 550. Okay, that is 55 into 21. Rupees 1155. 1155 is your answer. The total cost of whitewashing will be rupees 1155. So I hope whatever we discussed today, the sums that I told you, it must be clear to you. So in the next class, we'll continue with few more questions, and I'll tell you about sphere and hemisphere also.